So we will solve some numericals related to your last class theory. Okay, so that is the first numerical is what force is required to stretch a steel wire of 1 centimeter in cross section, that is the area, to double its length. Okay, we have to double its length, and here given y means Young's modulus. Okay, Young's modulus is given. Young's modulus is 2 into 10 to the power 11 Newton per meter square. That we need to find it out. Okay, so we need to find out the force. Okay, so first of all, let us find out the common thing. What is that? The area for the given data is area is given 1 centimeter square and y is given to us. These are two given datas. Along with that, we have another data hidden here. What is that? That is already the length is how much? L. Okay, and according to the question, what it is given, we have to double its length. Suppose the L previous length is L. Okay, after elongation, how much it will become? Another L, right? So what is the change in length? The change in length is this section. Okay, here to here, this portion is the change in length, right? So what is the value of the delta L? Delta L is equal to L. Are you getting my point? Okay, so the thing is that if we will double the length, then the elongated length will be same as that of your previous length, right? So what will be our delta L? Delta L equal to L. All of you draw the diagram and write this one, delta L equal to L. Okay, so this is the data given here. Okay, so let me write down the data. Here you can write it as your L equal to delta L, okay, is equal to L. Okay, another one is your area, that is 1 centimeter square. Okay, we need to convert it to meter square, right? So how much meter square it will become? It will become 10 to the power of minus 4 meter square. Okay, 1 centimeter square means what? 1 by of 100, as it is centimeter square, so another two zeros. Okay, so it is what? 10 to the power of minus 4. So area equal to 10 to the power minus 4 meter square, right? So this one is given, right? So now let us place the formula. Okay, and y is also given. Y data is given 2 into 10 to the power 11. So let us place the formula. The formula is y is equal to f upon a, as you can see that I have provided in the last class, f upon a into L by delta L. Okay, f upon a by into L by delta L. And according to the question, it is asked our force. So we need to find out our force. Okay, you can cancel it here, L and delta L, right? Because both are same. Okay, and what we need? Only force. So a will go here and will be multiplied with y. Okay, so write it down quickly. Okay, so now the formula is f is equal to, okay, I can write f is equal to y into a. Okay, so what is my y? Y is 2 into 10 to the power 11, and what is a? 10 to the power minus 4. Okay, so if you will solve, this is minus 4, 2 into 10 to the power 7 Newton. 2 into 10 to the power 7 Newton. Okay, so the answer is 2 into 10 to the power 7 Newton. Okay, shall I rub? Anyone? Just anyone answer? Shall I rub? Okay. Now, moving on to the next question. Okay. The next question is, what load when suspended, okay, it is asking us the mass. What load when suspended from a aluminum wire of 2 mm in diameter, the diameter is given how much, 2 mm, and 5 meter long, will stretch it by 1 mm, okay, will stretch it by 1 mm, okay. That means the wire will be, let me draw the diagram again. The wire will be, if this is the wire, it will be stretched up to 1 mm, right, 1 mm. What is this portion? This portion is only how much, 1 mm, okay. And this data 1 mm is what? This data 1 mm is nothing but your delta L, okay. The change in length we are representing with elongated length, okay. All this what represented with symbol delta L. So delta L data is given how much, 1 mm, and obviously Young's modulus is given as 7 into 10 to the power 10 Newton per meter square. So we need to find what load when suspended from the aluminum wire. So we need to find what load must have to be attached with the aluminum wire, okay. What load, this is the load we need to find, so that it will be elongated, this wire will be elongated up to how much, up to, it will be elongated up to 1 mm, okay. This elongated length will be 1 mm, okay. So now let us write down the data, given data, all of you write down, okay. The thing is, we need to find out, as we need to find the area, the radius is a must requirement, right. So r is equal to d by 2, okay. R is equal to d by 2, okay. So d is how much, d is given here as 1 mm, right, 1 mm, okay. Or yes, here you given, okay, sorry, 2 mm is given, okay. 2 mm divided by 2 will be, answer is 1 mm, okay. So 1 mm is how much meter, we need to convert it to meter because it's a requirement according to the unit. So 1 mm is 10 to the power minus 3 meter, okay. 1 mm is 10 to the power minus 3 meter, okay. And our length is also given, length is 5 meter, okay. And delta L, delta L is given 1 mm, again it will be of 10 to the power minus 3 meter, right. So these are the things given, along with Young's modulus, the y data is also given, okay. Y is equal to 7 into 10 to the power 10, this data is also given, y data, okay. 7 into 10 to the power 10 Newton per meter square, right. Done. Shall I rub? Okay, okay. Now let me write down the formula. Y is equal to Young's modulus formula, F by A into L by of delta L, right. F by A into L by of delta L, right. Here F I can write it as mg, okay, divided by area as pi r square, okay, into L by delta L, okay, into L by delta L. This is what equal to, y equal to, right. And what I need this mass m, okay. So that means these two, pi r square into delta L will go there, will be multiplied with y, and this g and L will be divided by that particular one, right. So let me arrange it, okay. Just rearranging this equation, I will get it as, I think all of you wrote. Shall I rub? Okay. So now you can get it this one as m is equal to pi r square into delta L into y divided by g into L, right. Now placing the formulas, pi, this r square is 10 to the power minus 3 square into delta L is 10 to the power minus 3. Then y is how much? 7 into 10 to the power 10. Okay, this is the y value, whole divided by g is your 9.8 multiplied with 5. Write down all of you. Shall I rub? Yes or no? Okay, right. So now this answer is, you will get the answer 4.485 kg. This mass has to be attached with that aluminum wire of 2 mm in diameter. Okay, this mass has to be attached. Then only it will be elongated to an length, that is delta L is equal to 1 mm. Okay, now moving on to the next question. The next question is, a cable is replaced by another one of the same length and material, but twice the diameter. Okay, but twice the diameter. Okay, one cable is there. Okay, it is replaced by another one of the same length but of the different diameter. The diameter is now quite different. The length is same but the diameter is different. How will this means this diameter, how will this diameter affect the elongation under a given load? That means this question is asking us the expression. It is asking us how will this diameter is going to affect our given load, right? Elongation under the given load. That means it is asking us what is the relation between d and length. Okay, d and length, this is our first question. Affect the elongation. Okay, d and L. Okay, next one is, second question is, how does this affect the maximum load it can support without exceeding the elastic limit? Second one is, how does this affect, how does this means what, diameter, affect the maximum load it can support without exceeding the elastic limit? Maximum load, that means mass. Okay, or you can say mg. Okay, it is now relation of mg with that of d. The second question is, what is the relation between mg and d? So now let us find it out. This is only the equation results that we are going to achieve here. So let us write down the Young's modulus formula first. Y equal to mgl. Okay, that is another formula, you can check your notes. Mgl divided by pi r square, okay, into delta L. Mgl whole divided by pi r square into delta L. Okay, here r, what is r? Radius. Radius is what? Radius is nothing but diameter by 2. Okay, so what is r square? Diameter square, d by 2's whole square, right? D by 2's whole square. So here in the r I will replace it with d by 2. Okay, all of you write it first. Shall I rub? Okay, so this one is y equal to, I can write mgl whole divided by pi, instead of that r I can write it as d by 2's whole square. Okay, d by 2's whole square multiplied with delta L. Okay, So this will become what? D by 2's whole square will become d square by 4. Okay, and this 4, okay, d square by 4, this 4 will go to the numerator side and will be multiplied with this one, right? This I am going to do. Okay, I think all of you wrote. Let me rub it. Yes. Now the next point is I have to write it. This will become 4 mgl whole divided by pi d square. Okay, the d square by 4, this one was there, and this as went to this numerator side, pi d square into delta L. This is the main equation. Y is equal to. Okay, now exactly I need the relation between first one is elongation, that is the length, as with that of the diameter. Okay, the elongation and the diameter. Elongation is what? Delta L. Okay, so I need to get the relation between delta L and Y. Okay, so now let me take this delta L to this side and this Y to this side. Okay, now let me write it clearly. This will become delta L is equal to, just reversing, nothing else, 4 mgl whole divided by pi d square y. Okay, pi d square y. Now see the relation. Here delta L is inversely proportional to d square. Okay, write it simultaneously. Now from here I got the relation delta L. Let me write it clearly. Delta L is inversely proportional to 1 by d square. Right? Now, what is the question telling us? If the diameter is twice, okay, if I will make the diameter twice, okay, if I will make the diameter twice, what will be the relation? The relation is delta S is directly proportional to 1 by 2d square. Okay, that will become 1 by 4d square. Okay, it will become 4d square. If the diameter was d, and the next time when the diameter will become 2d, okay, how much it will affect? This is will become 2d square. If it is 2d square, what will be the answer? 1 by 4d square. Okay, write down everyone. Okay, then write clearly, if the diameter is doubled, clearly if the diameter is doubled, the elongation will become 1/4. Write down clearly. If the diameter is doubled, the elongation will become 1/4. See here, the elongation is now 1/4. Okay. If the diameter is doubled, then the elongation will become 1/4. Okay. Now let me write down another formula and find out. Let me find the relation again. Shall I rub? Okay. Okay, so right, this will be next question is diameter and load relation. Okay, that is, I have the equation as what? Don't write, you have this one in your notebook. 4 mgl divided by pi d square. Okay, pi d square into delta L. This is the relation. Okay, let me keep mg this side and take all these datas to this side. Okay, just interchange. Okay, and after interchanging this one, I will get the equation as mg is equal to, write down everyone, mg is equal to pi d square multiplied with delta L multiplied with y whole divided by 4 into L. 4 into L. And clearly you can get the relation here. Okay, you can get the relation here clearly. Mg is directly proportional to d square. Okay, so let me write down again. Mg is directly proportional to d square. right? Now let me place according to the question. If the diameter is doubled, then what will happen to the load? If this diameter will become 2d, then this relation mg is will become 2d square will become 4d square, right? If I will place this d is equal to 2d, okay, I will place here instead of d it will become 2d, so 2d square will become 4d square. So mg is directly proportional to what? 4d square, right? Okay, so now here what it is representing us? It is representing us, write down clearly, if the diameter is doubled, if the diameter is doubled, the wire can support, if the diameter is doubled, the wire can support 4 times the original load. If the diameter is doubled, the wire can support 4 times the original load. Okay, clear everyone? Yes or no? Shall I rub? Yeah. Okay, moving on to the next question. The next question is compute the elongation, okay, compute the elongation of the steel and the brass wires. Two wires are there, one is of steel, another one is of brass. In unloaded length of steel wire is equal to 1.5 meter. Don't worry about the questions, I am going to send it, don't worry. Okay, don't write the questions also, only write the answers. Compute the elongation of the steel and brass wires in unloaded length of steel wire is equal to 1.5 meter. Okay, steel wire's length is 1.5 meter. Unloaded length of the brass wire is 1 meter. And the diameter of the each wire, okay, given here, the diameter of the each wire is 0.25 centimeter. Young's modulus of the steel is 2.2 into 10 to the power 11 Pascal, right? And that of your brass is 0.91 into 10 to the power 11 Pascal. Okay, Newton meters, another what you can say abbreviation is your Pascal, another unit is also Pascal, right? So Young's modulus, another unit, instead of Newton meter you can write it as Pascal. Okay, this is another unit, the same form. Okay, so now let us see in detail. Okay, first all of you draw this diagram. Okay, what we need to find, all of you catch here, we have to calculate, compute the elongation. That means we have to find delta L, as the word indicates, delta L in both the cases. Okay, first all of you draw this diagram. Let me draw the diagram so that you can draw it clearly. So here one mass is attached, this is of 4 kg. Here another mass is being attached, okay, this is of 6 kg. Okay, this length of the wire is 1 meter, this length of the wire is 1.5 meter. First wire is of steel, second wire is of brass. And two loads are being attached like this. Okay, are you getting my point? All of you draw it. Okay, and you can check here in this diagram while drawing this one, the steel wire, okay, the steel wire is going to take the load of two things, one is 4 kg, another one is 6 kg. Again the steel wire is going to feel the load of how much, 4 kg plus 6 kg. But the brass wire, this is the brass wire, this brass wire is going to get the load of only 6 kg because of the 6 kg, right? So according to the data, let me write it. All of you drawn? Anyone? Shall I rub? Okay. Now let us write down the data first. L1 is given. L1 means for the steel wire. Okay, this calculation is for steel, so give the heading steel. Okay, so for the steel wire you can write it down. L1, the length one is given 1.5 meter, as you can see the diagram, 1.5 meter. The radius I need to find, radius R1, that is diameter by 2. Diameter is given 0.25 divided by 2. This is in centimeter, right? So this will give me, I have to convert into meter. Okay, this will give me 0.125. If I will multiply with 10 to the power minus 2, this will become meter. Okay, another quantity is what? The force that is going to experience by this one, force F1 is equal to, one is the weight 6 kg, another one is 4 kg multiplied with 9.8 mg, right? So 6 plus 4 into 9.8 Newton. Along with that, y1 is also given, that is Young's modulus for the steel wire, that is 2 into 10 to the power 11. All these datas are given to me. This one, and this radius. Okay, so shall I rub? Yeah, okay. So this is, I can write it as y is equal to F by A into L by delta L. This is the as usual formula. And instead of A here, cross-sectional formula, let me place F by pi r square into L by of delta L. Right? So now let me find out delta L from this, because my question is what? To find out the delta L, and I need to find out this one, delta L. Okay, so how can I will find? Let me replace it. Okay, this delta L will go here and this y will come here. Okay, and let me write down the formula again. Okay, I think all of you wrote. Let me write down the formula for delta L. Just by interchanging this one, delta L is equal to F by pi r square, F by pi r square, okay, into L by y. Okay, F1, and let me write this L1, L1, Y1, R1 like this. Because we are finding for the steel, let us represent with 1 each. Okay, now let me place the value. This is F is 10 into 6 plus 4 is 10, right? So 10 into 9.8, this is F1. And your L1 is given 1.5. This is pi r square, pi into r1 square is how much? 0.125 into 10 to the power minus 2's whole square multiplied with y1. y1 value is 2 into 10 to the power 11. Okay, all of you write it. I think done. Shall I rub? Okay, so the answer you will achieve as delta L1 is equal to 1.5 into 10 to the power minus 4 meter. The answer you will get, delta L1 is equal to 1.5 into 10 to the power minus 4 meter. Okay. Now let us find out for the brass wire. Give the heading for the brass wire, right? Here I have to write the formula given data again. L2 as 1 meter, R2 as same because the diameter is same for both the wires, so it is also same as that of before, no need to calculate again. 0.125 into 10 to the power minus 2 meter, this is R2. And F2, the brass wire is going to achieve the load of only because of 6 kg, so this is 6 into 9.8, okay, M into G. This is F2, and Y2 data is given, okay. Y2 data is 0.91 into 10 to the power 11 Pascal. This is given in the question, okay. Shall I rub it? Okay, so now let me write down delta L2 as according to the previous formula just now, only to copy that one. F2 into L2 divided by pi R2 square multiplied with Y2, okay. So this is 6 into 9.8, this F2, this is F2 value, okay, into L2. L2 is how much? 1 whole divided by pi into R2 square, that is 0.125 25 into 10 to the power minus 2 square multiplied with 0.9, okay, into 10 to the power 11, okay, 0.9 into 10 to the power 11. Zero 0.9 into 10 to the power 11. This is the Y2 value. Shall I rub? Okay, so now this one over. So now let me write down the answer. All of you also write, and you have to check it through your calculator. The answer is 1.3 into 10 to the power minus 4 meter. The answer is 1.3 into 10 to the power minus 4 meter. This is the answer.